And so astronomers have taken all of these facts and figures about different stars in our universe, and they have put them onto one diagram called the Hertzsprung-Russell diagram, or the HR diagram. So let's analyze the various parts to the HR diagram. Vertical information. So if we go back to the HR diagram, you'll see that it has vertical information and then it's got horizontal information. So the vertical information is going to be the brightness of these stars compared to the brightness of the sun. And so the very dim stars are going to be at the bottom of the chart, and the very bright stars are going to be at the top of the chart. So if we go back here and now look at the HR diagram, you'll see that there's numbers that are going up and down, and the small numbers are down here, and then the big numbers are up at the top. And so that's how many times brighter these stars are in comparison to the sun. So do you remember that L sub 0 thing? Okay, now find 1. So on that chart there, see if you can locate where 1 is located at. Okay, so 1 is roughly right about here. Okay, now I want you to go sideways until you get to this thing here, which is going to be called the main sequence. Do you notice what's there? The sun, because the sun has a brightness of 1 times the brightness of the sun. So the sun is going to be right here on what's going to be referred to as the main sequence, and we'll talk more about what the main sequence is in just a moment. Okay, got that? All right, so let's keep going. Next, let's look at the horizontal information on the HR diagram. Well, one thing you should notice is the temperature. So the low numbers are on this side, and the high numbers are on this side over here. So you're going to have the cooler stars, the ones that have a cooler surface temperature, are on this side of the chart, and then as you go in this direction, they get hotter and hotter. So do you remember what the surface temperature of the sun was? About 6,000. So see if you can find 6,000 on here, and then so it's going to turn out to be right about here, and then go up. So once you've got that 6,000, go up, and you notice you end up right where the sun is at. So again, the sun has a surface temperature of roughly 6,000 Kelvin. So that's one piece of information going sideways. Another piece of information going sideways is the color. So do you notice that on this side over here you got the reds, and then next to the reds are the oranges, and then next to the oranges are the yellows, and then next to them are the whites, and then over here are the blues. So that as the temperature is getting hotter, the color of the stars are changing. And again, look at the sun, and you'll notice it's that yellowish, whitish color. Okay, another thing that you see is, do you notice that there are letters as you go across? So those are the different spectral types. And you remember that we said that depending on the letter, that a different element would appear in its spectrum. And so those are the different letters. Now if you're in my class, don't worry about the spectral types. So that would not be on the exam. Okay, let's keep going. So the next thing is diagonal information. So if you will notice very carefully in that picture, there are some diagonal lines. And so those diagonal lines, represent the different radiuses. So the small diameter stars are down at the bottom, and then as we go up, so this would be a small diameter star, this one would be a bigger diameter star, and then this one would be bigger still, and they're in terms of the radius of the sun. So find one. So find on this picture here, can you spot where you've got one solar radius, a radius of 1? Well, you might notice that it goes right through the sun there. And again, that just tells you that the chart is correct, because it's telling you that the size of our sun is 1 times the size of our sun. Okay, what's another piece of information? Other information on the chart, you might notice that there are some purple numbers, and you might also notice that there are some green numbers on this chart. So what I recommend is, this is kind of hard to see, so you can pause me and then increase the magnification so that you can read the stuff on there, or just go to the internet and find one of these HR diagrams. So all the diagrams are basically the same. So if you look closely, you're going to see some purple numbers, and then that's the mass of the star in terms of the mass of the sun. So you're going to see that some of those purple numbers say 100. And so that would mean that that particular star is 100 times the mass of the sun. And then you'll also notice that there are some green numbers, and those green numbers indicate how long that star is going to live. Because stars are born, stars live, and then stars die. So this is going to tell you how long that star is going to be living. And that's in green on this chart. And I want you to see some characteristics here, so that up here at the top is where you've got the very massive stars. And then down here, this is where the little stars are. So little stars are down here, the big stars are up here, and as far as lifetime is concerned, the ones with the shortest lifetime, they don't live very long, are up here. And the ones that live the longest are going to be down here. So where's the sun? Well, it's in the middle. So our sun has been around for about 5 billion years, and it's going to be around for about another 5 billion years. So it has an average lifetime of about 10 billion years. But up here, you find that some of these might only live for a few million years before they die. And then down here, you might find that some of these are going to live for 100 million years, or maybe even 1 trillion years before they die. So that's the HR diagram and the different parts to it. One other thing, so let's talk about the regions on the HR diagram. So this thing here, where you have a whole bunch of stars making that band, this is going to be called the main sequence, and these are stars that are living. They are currently converting hydrogen into helium. They are living. Okay, but then when they start to die, they go off the main sequence. Now they're not physically moving through space. So what they're doing though is, so this is not a map of outer space. So this is just showing you where the various properties of these stars is at. So when one of these stars on the main sequence starts to die, it's going to migrate over into this region where you're going to have the giants. So this is where you can have red giants, you can have blue giants, but these are going to be giants, and they are going to be dying. So they're going to be making heavier elements heavier than helium. are going to be made in these objects over here. So they're in the process of dying. Then you also have this region down here. So this region is going to be where the white dwarfs are at, and these stars have died. So they're dead. They're very, very slowly cooling off when they're in this region over here, but they don't have really active nuclear reactions going on in their cores anymore when they're a white dwarf and they're over here. Okay. So here is a sample question. So I will let you do this one. You will need a HR diagram. So I would get an HR diagram off the internet in order to do this. But what I want you to do is find the star Spica on there, and then I want you to tell me what color is it, what temperature is it, what brightness it is, what's its radius, what's its mass, and how long is it going to live. Don't look at the bottom. So once you've figured that out, then look at the numbers there at the bottom and see how close you got. All right. Well, it's time to take the quiz. So let's take a break. We'll come back and we'll wrap things up by taking a quiz.